Okay, so let's take a look at the example. So let's read it first again. If wet laundry loses half its moisture in the first 5 minutes in a dryer, and if the rate of loss of moisture is proportional to the moisture content, then when will the laundry be practically dry, defined as having lost 95% of its moisture or having 5% of moisture left? Okay, the first step to solving this question is to define what it is we're trying to solve for. What is the variable? What's the thing that we want to solve for? And when you read the question, that is the moisture content. So what we need to do is we need to have a variable. What we'll say is let y of t, okay, be the moisture content. Okay, so that's the first thing. And when you read the question, it says that it has some initial amount of moisture. So let's look at the initial conditions. Okay, at time t, right? At time t in minutes. Okay, so that's step one. All right, so what do we know at the beginning? We know, well, y of 0 is equal to something. It's equal to the initial moisture content at time 0. Okay, we don't know exactly what this is, but we know that at some point it's going to be at 5% of this value. Okay, so we also know that it says here at y equals 5 minutes, right? We know that it loses half of its initial moisture content, right? We have it loses, okay, loses half of initial moisture content. Okay, in the first 5 minutes. Also in the question is a relationship. Okay, it says that the rate of loss of moisture, what is the rate of loss of moisture? Well, that is dy of t by dt. Okay, that is it says the rate of loss of moisture. Now, whenever you see that is proportional to, okay, what that means is that there is a proportionality constant that makes it equal to. So whenever you hear the words is proportional to, that means that you put an equals k times, and then it says is proportional to the moisture content. Well, that is k times y of t. Y of t is the moisture content. Okay? All right. So now we have a differential equation, right? We have a y prime, right, equals k times y. Now, like we said before, we're going to solve by separation of variables. So what we need to do here is we can't have any dy's or dt's in the denominator. So we're going to multiply both sides here by dt. So if we multiply the left side by dt, we're just left with dy. We can leave the t out. If we multiply the right side by dt, right, because whatever we do to one side, we do to the other. Okay, y of t dt. Now, we still have not yet separated the variables. Well, why? Because we have to remove the y here. I can just get rid of this function of t here just to make things nice and simple. So now I have to divide. So I multiply by dt. That's the first step. The next step is to divide both sides by y. this cancels out. So what I have is dy over y equals k dt. Now, what I can do is I can solve this by integrating both sides. So I'm going to integrate this side, and I'm going to integrate this side. Okay, so really, what does this look like? Let me just move this up a little bit here. What this is the integral of 1 over y dy is equal to k integral dt. Well, what's the integral of 1 over y? Well, the integral of 1 over y is ln magnitude of y. Now, I could go plus c1, right? Because this integration here is going to give me some constant. And what's the integral of dt? Or it's just k times t plus some other, okay, constant of integration. I can then go and combine these two. I can combine c1 and c2. So I could say that my solution is ln of y is equal to, okay, k t plus, I don't know, I'll just make this c. Where here c is equal to c2 minus c1. Okay? All right. So I could, if I wanted to, ln has a base of e, right? So what I could say is that y equals, if I wanted to, this is a perfectly good solution, but what I could say is e to the kt plus c. So e to this equals y, right? E to everything on the right hand side equals y. Well, look, this is the same thing as e to the kt times e to the c, right? Now this is a constant, right? So what I could do is I could just say, I could call this guy right here c naught. So what the solution is c naught, just another constant, e to the kt. That's this is one solution right here. This is also the same, another way of writing the exact same solution. Okay? Now, if I want to solve for c naught in either of these two solutions, I need to sub in the initial conditions. So what are those initial conditions? Okay, so I can, now depending on which one I choose, sometimes the first solution is easier to deal with than the second solution. Okay, sometimes it's easier to work with this in terms of ln than it is in terms of exponentials. So I'm gonna go with that for now. So I'll use this first solution. This is the same thing, number 2. Okay, they're both solutions, but right now these are the general solutions because we have c's. But since we have an initial condition, we have y at 0 equals y0, and y at 5 equals 0.5 y0. Okay, so we have those two. If we go up here, these are, and what I should do is I should tell you, these are the initial conditions. Okay, these are the initial conditions for the problem. Okay, so let's go through. So we say y at 0 equals y0. So what does this tell us? What does this tell us? Well, let's go with it doesn't matter which form we use. I'm going to go with form number 1 as the solution. So if I say y at 0 equals y0, right? So we said y at t equals 0 equals y0, and we're going to sub that into equation number 1. So what do we get? We get ln, okay, let's rewrite it, equals kt plus c. Okay, so we said that ln of y is 0, so it's y0, when t equals 0 is equal to k times 0 plus c. This tells us that c is equal to ln of y0 in this form, right? When it's in that form. So this is initial condition 1, number 1. Okay, so this tells us that c is ln of y0. So what this tells us is if we use this equation, ln of y equals kt plus. So that tells us that the equation 1 is ln of y equals kt plus ln of y naught. That's c in that form. Now, what else can we do? Well, we have another variable that we don't know. We don't know what k is, right? We didn't know what c is or k is, so we needed two equations to solve. So we have one equation we use for c. Now we're going to use the next equation to solve for k. So we have the initial condition, number 2. And that is that y at 5 minutes is equal to 0.5 y naught. And we're going to sub this into our equation. Okay, so we're using 1 again. So ln of, I'll just rewrite it just so that you know, and then we'll sub it. I know I'm doing it a little bit more slowly, but that's okay. So when t equals 5, so here we're going t is 5, okay, ln of y0 is c, then y equals, so y here is 0.5 y naught. Okay, and we can use this now. Now we want to solve for k. So what do we have? We have 5k equals ln of 0.5 y naught, and here minus ln of y0. Okay? And so what we can do here is basically, okay, we can take this guy, divide both sides by 5, so I'll just divide that by 5. So that's my solution for k. So what are we left with here, right? We know that there's an equation here. This is an identity for lns. So if you have ln of a minus ln of b, that is the same thing as ln of a over b. Okay, so what does that mean? Well, this identity, okay, can be used here. So we're saying that k is equal to that. So that means that this is the same thing as ln of, okay, we can put it's 0.5 y naught over y naught divided by 5. So the y naughts cancel. Okay, so we have a ln, so that k equals ln of 0.5 over 5. Okay, so that's k. Okay, so now our equation simplifies even further. We have, so our equation, again, in the ln form, we have ln of y is equal to, what's k? Well, k is ln of 0.5 over 5 times t plus ln of y0. Okay, so now this is our differential equation. Okay, this is, we solved for y in terms of t. We don't have to solve for y explicitly. Let's leave it in this form, because what we need to do next is the question asks us, it says, when will the laundry be practically dry? That's a time in minutes, right? So what we need to do is we need to solve for t here. So in order to solve for t, what we need to do is bring this ln over to the other side of the equation, multiply by 5, divide by ln of 0.5. So what we have is we have that t is equal to, we have our ln of y, we bring the ln of y naught, okay, and then we have to take this guy, multiply that by 5, and then divide by ln of 0.5, and that becomes our t. Now we can take this. This becomes, this ln of y minus ln of y naught becomes the ratio of, here, let me move this up. Let's make more space here. This becomes, so t equals, it becomes 5. So it becomes ln of y over y naught divided by ln of 0.5. Okay, so now it says, when will it be practically dry? So what that means is that we will have, so 95% of the moisture is gone. So that means that we have 5% of the moisture left over. What does that mean? Well, that means, okay, so practically dry. Practically dry means that y is equal to 0.05 y naught. 95% of the moisture is gone, so it only has 5% of its original moisture content. Okay, so that's basically what we need to do. We need to sub in y equals 0.05 y naught into this equation and then get t. So that means that t is equal to 5 ln. Now we have 0.05 y naught divided by y naught, so that's just going to cancel. So we have ln of 0.05 over ln of 0.5. Okay, and when you plug that in, all times 5, okay, you get 21.6 minutes, right? 21 minutes, and then what's 60% of 60 is like 36 seconds, right? So anyway, whatever. 21.6 minutes. All right, I hope you enjoyed this video and that you learned something. I'm going to zoom out for you just to show you the complete solution here. Okay, you'll also find this solution in the PowerPoint slides. So I hope you enjoyed it. Have a great day.